Hello everyone, I am Sai Chandra. Today we are going to discuss about difference between histogram equalization and histogram matching. Before getting into our topic, we need to understand what is contrast. Contrast refers to the variation of intensity levels in an image. If the contrast of an image is high, then there are more intensity values and it is more distinguishable. Whereas in a low contrast image, the intensity values are less and it is not easy to distinguish between colors. Here you can see that the green color is very less in intensity values because the image is of low contrast, whereas in a high contrast image there are more intensity values, so the colors pop out more. To improve the contrast of our image, we use various techniques like histogram equalization and histogram matching. Generally, a high contrast image has a wide range of intensity values and the distribution of pixels is equal. Histogram equalization stretches out the range of the intensity values in an image to produce high contrast images. Let us understand how histogram equalization works using an example. Here we can see that the image has a low contrast and we cannot observe many details in the black region. So we need to apply histogram equalization to find out more features about this image. Firstly, we need to create a transfer function such that we can equalize our image and increase the intensity range of our image. So we take a transfer function t such that it is monotonically increasing and the range of the input intensity values is between 0 and L minus 1. Here L refers to the maximum intensity value of our image. Moreover, we need to make sure that the output value rise between 0 and L minus 1. We take the transfer function as monotonically increasing so that the relation between input and output is a one-on-one relation. To find the transfer function of histogram equalization, we use this formula where L minus 1 into summation P of R from 0 to K is taken. Here, the summation refers to the cumulative density function for each intensity value. Instead of using probability, we can simply write as Nj by M into N. Here, Nj is the number of times the pixel occurs for each intensity value, and M into N is the dimension of our image. Here you can see that this is original histogram with probabilities for each intensity values, and this is a transfer function which we apply to our original image. After equalization, we get this histogram where the probability of each intensity value is almost equal. So we can clearly observe that the dark areas of our image has increased in brightness and we can clearly observe features of our image. We can calculate histogram matching by following steps. In step 1, we need to calculate histogram equalization of our input image from the formula we have previously discussed. Then, we need to also find histogram equalization of the specified histogram, according to which the output of our image will depend. In the third step, we need to match the value of output intensity values to the specified histogram values, and we need to store it in a table. Then, we need to map the specified histogram's input values to our equalized output image, and we need to calculate the ZQ. After applying histogram matching, we can see that there is a slight difference in our output image. Here, we can observe the increase in the brightness of the darker image while maintaining the features of the lighter image. So, a small change in the histogram matching can bring in various drastic results. This is a Matlab implementation of histogram equalization. First, we need to find the number of pixels by multiplying rows and columns of our image. Then, we will display the histogram of our input image, which can be seen here. Then we declare variables like frequency, which calculates the occurrence of each pixel in our image. Then we need to calculate probability, which can be used by this variable. Here we increase the value of frequency for each occurrence and calculate its probability by dividing the total number of pixels. Then we need to calculate CDF of each pixel. Here we use the variable sum to increase the value of frequency for each pixel. Then we calculate cumulative probability by dividing this by number of pixels. Then the output is the approximate value of cumulative probability multiplied with total number of pixels, which is declared by a number of bins. Then we will display the histogram of our output image, which can be seen here. This is a Matlab implementation of histogram matching. First, we need to take the histogram of our input image and our reference histogram. Then, we need to calculate CDF of these both by dividing the cumulative probability by the total number of pixels. Then, we will find the index of each pixel value of our input image where the both CDF are almost close to equal, and we store it in the array M. Afterwards, we will declare a variable mat which is of the size of our image, and we will give the value of each pixel value which we have calculated before. Then we get the output of our histogram matching, which is like this, and the histogram of our output image can be seen here. There are several applications of histogram equalization and histogram matching. Some of them are astronomy, medical field, and enhancing satellite images. One of the application can be seen here, where the MRI of our brain is taken. Here we cannot observe the features clearly because the image is dark. After applying histogram equalization, the image becomes bright and it becomes easier to identify tumors and cysts in our brain easily.